This video presentation is going to illustrate to you a second method of depreciation, referred to as the declining balance depreciation method. This is an alternative to the straight line method, and the declining balance method assumes that you're going to want to take more depreciation or prorate more depreciation in the early years by taking it away from the later years. In other words, we're going to push depreciation from the later years into the early years, whereas the straight line method gives you the same amount of depreciation each year. Now, this method could be chosen by a manager if they believe that the use pattern of the asset would be greater in the early years of ownership and less in the later years of ownership. This is one of two methods that will be presented in Agribusiness 3005, and it's not the only methods of depreciation. You will learn others when you take courses in accounting. To illustrate how this method works, we're going to start with a $75,000 purchase price, a 10-year life, and a $15,000 salvage value. Before we actually start the depreciation schedule, we needed to define a couple of terms and show you how they would be decided, values would be decided. The first thing is what we're going to refer to as an acceleration factor, and this has to do with how fast you would like to prorate that depreciation up into the earlier years. In other words, if you wanted the depreciation to be prorated 1.5 times as fast as the straight line method, you'd put a 1.5 there. If you wanted it to be twice as fast, you'd put a 2 there. If you wanted it to be 1 1/4, you'd put 1.25. Now for this illustration, I'm going to put a 2 here. A lot of times in accounting courses, by using a 2 for that acceleration factor, they refer to it as a double declining balance. Now, declining balance and double declining balance is really exactly the same thing, except the word double implies that you use a 2 right here. When we get to the income tax in this course, you will find that the number 1.5 is pretty common for that acceleration factor. Okay, the next thing is to calculate something we're going to refer to as the straight line rate. In other words, in the straight line method, you depreciated or prorated the same amount each year over the life. So to find that straight line rate, all we need to do right here is go equals 100% and divide it by the life. And that gives us what percent is prorated or depreciated each year. And you know that number's constant in the straight line rate because you'd have the same amount of annual depreciation. Okay? All right. The next thing is this thing called a declining balance factor. And this factor is what we're going to use in the declining balance equation, mathematical equation, for calculating the annual depreciation. And this factor is simply equal to the acceleration factor times the straight line rate. Now, it's important to understand this acceleration factor is a chosen factor by the person doing the depreciation. This straight line rate is a calculation based upon the economic life. And of course, this declining balance factor is also a calculated factor based upon the choice of the acceleration factor and the straight line rate. Now, let me show you. What if the life of this machine was 5 years? Okay? You see, all of a sudden, 5 years gives you a straight line rate of 20%. 100 divided by 5 is 20. And then when you double that, you'd have a 40%. Okay, let me go back and put this at 10, and let me show you how this works. Okay, now we have the necessary information to complete our depreciation schedule. When calculating the annual depreciation each year is equal to the declining balance factor times the undepreciated, and I'm going to abbreviate this, balance. Undepreciated balance. So in year one, if you were calculating the annual depreciation in year one, it would be equal to 20%. Now in year one, you haven't depreciated any of that purchase price. Okay? So that purchase price is $75,000. So here would be, we do not subtract the salvage value. So this would be $15,000. All right, so where would that go into our depreciation schedule? Right here, this is going to be equal to that 20% times that original $7,500. There's your $15,000. Now remember on the straight line rate, that number was 6,000. So you see that we're accelerating depreciation considerably. All right, your undepreciated balance will be equal to your original 75 minus that 15,000. So your balance goes to 60,000 the first year, and of course you've accumulated just that first year's depreciation. Okay, now the question is, what does the second year look like? Well, in year two, the annual depreciation in year two is equal to that depreciation uh, balance factor, excuse me, that declining balance factor, 20%, times the undepreciated amount, which in this case is 60,000. So that gives you $12,000 of depreciation in year number two. Right? So we go right here, we go equals, we go that 20%. Now I'm going to F4 that so that I'm going to make it a constant so I can use it in the following cells and not have to repeat typing all that. In other words, I can autofill the cells. And I'm going to multiply that by the previous year's balance, and there's the 12,000. Now the undepreciated balance will be equal to the previous year, 60,000, minus the 12,000 for this current year. Okay? And now the accumulated depreciation, of course, will be equal to the previous year's plus the next year's depreciation. Okay? Now, the third year, let's go and do one more. The annual depreciation in the third year is going to be equal to 0.2 times 48,000, which will be $9,600. Right, so we'll go put that in the table and show you right here. It's going to be equal to, there's that declining balance factor. Once again, now I'm going to F4 that to freeze it, times the previous year's balance. I'm not going to freeze that because I'm going to need that to adjust. There's the 9,600. The undepreciated balance, of course, is equal to the 48,000 of the previous year minus the depreciation of the current year. And the accumulated depreciation is simply equal to the previous year's total plus the current year total. Okay. Now, in order to complete that table, I can simply take these formulas now and copy them down, and you'll see what the entire depreciation schedule looks like. Okay. Now, here's where we want to be careful. Most references will illustrate to you that you should not depreciate this item beyond its salvage value. But if you'll notice, the undepreciated balance in year 7 right here falls to almost to the salvage value, and in year number 8 it actually falls below the salvage value. Now, you remember on the straight line method, at the end of the 10th year, you had the salvage value. But you see, in the declining balance, we actually dropped through that salvage value right here in year number 8. The undepreciated balance drops underneath salvage. So the way that the declining balance should work, if we'll go in here and modify this a little, right here in year 8, the annual depreciation should be just enough to get this balance right here to the salvage value. So what I would actually do is go right here and put $729. Okay? And then what I would want to do is get rid of these other years. Now, you can see that this machine actually gets down to its salvage value in year number 8. Now, you could have carried this on down many, many years, and your undepreciated balance would have continued to fall. But the typical way this is taught is that in the year in which you actually pass through the salvage value, that you put just enough depreciation to get you to that salvage value, and then there wouldn't be any allocation or proration of depreciation in years 9 and 10. I recommend that you watch this little short video a couple of times. I've noticed over the years that students struggle a little bit with the concept of declining balance. A couple of things to review real quickly. Remember that acceleration factor is chosen by the user. It's typically a 1 1/4, 1 1/2, or a 2. 2 is a very common term or common factor used in what's referred to as double declining balance, but it's still just declining balance with that factor it's set at 2. Remember, the straight line rate is simply 100% divided by the estimated life so that you get a constant amount each year when you're doing straight line. And then the declining balance factor is your acceleration factor times the straight line rate. Also, remember, in the first year, you multiply that declining balance factor times the original purchase price. You did not subtract the salvage value. So it's not 75,000 minus 15,000 in this illustration times 20%. It is the original 75,000. And then each year you multiply that factor. You leave it constant, but you multiply it by that falling undepreciated balance. When you look at the very bottom of the depreciation schedule, just like in the straight line, your balance is sitting at that salvage value, and the salvage value and the accumulated depreciation will again add up to the original purchase price. You should build you a depreciation schedule based on declining balance and have it set up where you could choose any number here from 1.25, 1.5, or 2, and you would calculate your declining balance factor, would also calculate your straight line rate, and then it would build you this depreciation schedule. Now, of course, based on what you put up here, the year in which you actually hit salvage value may change, but you can do that manually once the depreciation schedule is completed. When we take our next quiz, I will give you purchase prices, estimated life, salvage values, and acceleration factor, and actually ask you for numbers. It would be somewhere in this table.